All right, so let's go over some of these quizzes because this is the review for the test. And the test is going to look just like the quizzes, all right? Except the numbers are going to be just a little bit different. Do you have your quizzes on you? Do you keep a notebook where you put all your papers? No? You should. Toss them. It's not a good idea. Well, I'm not asking. Don't want you to lie. All right, here we go. All the natural numbers. I'm going to go through these pretty quick. All right. All the natural numbers. What are the natural numbers? They start at what?
0.
No. 1. Natural numbers are counting numbers. Same thing. They start at 1. And it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Keep on going. So which one of those is this? Is -3 natural? No. 3/4? No. What's the...
12.
It's 0.12. Just 10. So 10 is the only natural number. What about integers? Integers are all the whole numbers plus the negative whole numbers, if you want to think of it that way. All right, so there's no fractions, no decimals, no square roots or anything like that. Which ones are integers? -3 is. Is that? No, 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 no. Yeah, 10 is. What about 2.151515? No, that's it. Just -3 and 10. Those are your integers. What's a rational number? Well, any number that comes out even, or is a decimal, or not just any decimal, but a decimal that repeats the pattern. Okay, any fraction is a rational number. Okay, and any decimal that repeats a pattern. Everybody got that? So, what about -3? Is that rational? Yes, because that it's you could write it over 1. -6 over 2, right? Would be so -3 is 1. What about 3/4? Definitely, because any fraction is a rational number. What about 0.12? Yeah, if the decimal repeats or stops, then it's rational. So 0.12 is 1. Square root of 2? No, because that decimal, because it will come out to a decimal, but will never repeat. Okay, never establish any kind of a pattern. All right, so not this one. What about pi? It's a decimal, 3.14, but does it stop at 14? No, it keeps on going, never repeats a pattern, so no. What about 10? Yes. What about 2.151515? Keep on going. Yes, 2.15, and I'll just put a little repeat thing over top of it. Okay? Those are all rational numbers. What's an irrational number? It's all the ones that are not rational. All right, so which ones of these were not rational? Square root of 2 and pi, and that is how you do that. Square root of 2 and pi. Everybody got it? Okay. Now I could put different numbers in here, but I might ask the same kind of things. Which ones are naturals, integers, rational, irrational? Everybody good? All right, let's do this real quick. A lot of these I got to go kind of quick because we got to do 3 quizzes in one class period, all right? So it says the sum. What does that mean for the sum? Addition. The sum of what? 3 and y. So it's 3 what? Plus y. That's the sum of 3 and y is. What does that mean in math? Equals. Equals what? The sum, again, we're going to add. What are we going to add? 2 and 2. So it's 2 plus 2. Now, do I actually have to solve for y and add 2 and 2? No, because I just want to write each statement as using the symbols, okay? So that's my answer right there. Okay, I don't have to simplify it. Just rewrite it with numbers and symbols, okay? Product, what does that mean? Multiply. What are we multiplying? 5 and 2. So how do I show that? 5 times 2. Do we have to write 5 times 2 is 10? No. All right, so 5 times 2, of course, equals is equals, and then what? 10, all right? And that's how you write it. Don't write 10 equals 10. It's not what they're asking you to do. They're just saying write the statement using the symbols, using numbers and multiplication and equal signs and all that stuff. So that is how you want to write that. Okay, let's do this. Now, I remember distinctly being so frustrated with some of you guys on this one. Yes, it's please excuse, remember this one? Please excuse my dear Aunt Sally. Which means parentheses first, then exponents, then what? Multiplication, division before you add and subtract. So let's take a look. So do you go 8 minus 4? No, because there's multiplication. So what do you do first? You do the multiplication first. Okay? I don't mind your answering, but it just seems like we're getting a little bit carried away, just a little bit on the verge. So what do we write? We go 8 minus, we do this first, which is what? 8. 8 minus 8 is 0. So don't go 8 minus 4 is 4 times 2 is 8. That's not your answer. You got to do multiplication first. Let's continue that with this. We do parentheses first, then we do multiplication. All right, so let's do this first. So this is 2. Now, you don't really need that dot there, do you, to show multiplication? What's 3 minus 5? Negative 2. And then plus 8 times 2 minus 1. Let's do now multiplication. We did the addition, we did the parentheses. Okay, now we do multiplication. There's no division, so we just do multiplication next. What's being multiplied? Those two and these two are being multiplied. So 2 times negative 2 is negative 4. And then this is a positive 8 times a positive 2, which is a plus 16, and then minus 1. Negative 4 plus 16 is 12. 12 minus 1 is 11. And that's how you do it. I am recording this, so if you need to go back and look, you can do that. Okay? What about this one? What's the most important thing to do when we add or subtract fractions? Find a common denominator. And I'm not going to go through all the teaching on why this is the common denominator. I'm just going to show it to you. The denominator is 2, so I need to write this with a denominator of 2, right? So it was 2 over 1, so I went 1 times 2, then I got to go 2 times 2, which is 4. So 4 over 2 is the same as 2, isn't it? Minus 1/2. Now I can subtract. I keep the denominator the same. Don't go 2 minus 2 is 0. I got a common denominator, I just keep the denominator there. Then I go 4 minus 1 is 3, and that's your answer. Don't write 1.5. Don't write 1.5. Just leave it 3 over 2. That's the best way to do it. Because look, what if you said, okay, I want to change that to a decimal, and what if you accidentally write 2.5? Then that would be wrong. Even though you did it right, if that's what you wrote as your answer, I'm going to mark that wrong. Everybody with me? So don't take any chances. Just keep it like that. As long as it's reduced, it's fine. Speaking of reducing, let's go to this. If I multiply, you could just multiply straight across the top and bottom, but then you got to simplify it, then it becomes a pain. So we're going to simplify it right now. Look, I got a 3 on the top. Does 3 go into 5? No. But does 3 go into 21? Yes, it does. 3 goes into 3 once. It goes into 21 7 times. What about 10? Does 10 go into 7? No, but 10 and 5, they divide into each other, right? 5 divides into 10. So 5 goes into 5 once, and 5 divides into 10 twice. What do I got left? I got 2 on top, 7 on the bottom, and that's all you do. Let's do this. This right here means, what are you doing to those two fractions? You're dividing, okay? You're dividing the fractions. So I take the top, 5 over 21. Instead of dividing, what do? I multiply by the reciprocal. That's right. I'm going to flip this one, all right? And I'm going to multiply it. So I'm going to put 35 on top, 2 on the bottom. And now we try to simplify. Does 5 go into 21? No. Does 5 go into 2 or 2 go into 5? No. But what about 35? Does something go into 35 and 21? 7 does. That's right. So 7 goes into 35 5 times. 7 divides into 21 3 times. Does 5 go into 3? No. Does 5 go into 2? No. Same thing here. So we can't simplify anymore. So what do? Multiply straight across the top. 5 times 5 is 25. Straight across the bottom, 3 times 2 is 6. That's your answer. Leave it like that. Don't change it to a decimal. Don't change it into a mixed number. Okay? Everybody good? I know I'm going quick, but you can always go back and watch it and pause it, think about it, write it down, and all that kind of stuff. Distributive property. That x is being multiplied by this parentheses. So you're going to multiply it by the first one, and then you're going to multiply it by the second one. So how do I write x times x? What is x times x? That's x squared. Then I put the sign, which is a minus, and then I go x times 4. How do I write x times 4? Yeah, 4x. And that is all you had to do. The next one was the hardest problem on the whole entire first quiz. All right? What do we call, we got two binomials. Do you remember we're multiplying through? We'll call it the what method? Remember that? What does the F stand for? First, next, outside, inside, last. So that's the order that you multiply things in, all right? So I take the first two terms, these two right here, multiply them together. We already did that once, didn't we? What's x times x? X squared. And then I do the outside terms, that's these two right here. Multiply those together. What's x times 1? 1x, or just x. You can put the 1 there, it's fine. Let's do the inside. These are the two inside ones. Multiply those together. Negative 4 times x, negative 4x. Then the last terms would be these two right here. Again, it's a negative 4, right? It's a minus 4, negative 4 times positive 1, which is negative 4. Do we leave it like that? No, we don't, because you can add like terms. So there's no other x squared, so I just write down x squared. What about this? This is a 1x minus 4. What's 1 minus 4? Negative 3, negative 3x, right? It's positive 1 minus 4. And then I just put a minus 4 right here because of that one. Can't do anything else with that, so you just leave it like that. One quiz down, 2 to go. When do we get out of here? 50? I don't know, I'm looking, hold on. College algebra, it's 50. All right, I got time. Got about 15 minutes. Should be able to do 2 quizzes in 15 minutes, do you think? Do you remember this quiz? All right, yeah, this was easy. Fill in the blank using less than, greater than, or equal. 5 is what to 6? No, it's not. It's less than. 5 is less than 6.
That looks like it's zero.
I said 6. I said 5 and 6. Anyway, it might look like a 0 from where you are, but that's a 6. All right, what about this one? Negative 1 and negative 2. Sometimes that's a little tricky. But look, if I did a number line, put a 0 here, that's negative 1, that's negative 2, correct? Which one's bigger? The one on the right is bigger. So negative 1 is what? Greater than negative 2. What about this? 1/4. That's right. 1/4 is the same thing as 0.25. It's just something you got to know. Right? There you go. All right, what about this one? X is greater than or equal to, so what kind of a circle? We're going to put a circle right on negative 2. It's going to be closed. How do you know it's closed? Because it could be equal to it. We close it in if it's equal. All right? I put a negative 2 right there. Right? It's greater than, so that's why I put it all the way to the left, because we're going to look at all the numbers that are bigger than negative 2. So I'm going to put I'm going to put a circle, then I'm going to close it in, and then I'm going to shade to the right. Okay? And that's it right there. Let's shade it in real good. There we go. All right? Everybody got that? That's how you graph that thing. What about this? X is less than. So where am I going to put that 5? Am I going to put it over here on the left? Put it over here a little further on the right. So we'll put a 5 right there. You don't even have to put other numbers in there. I don't care. Just put the 5 there. Right? But now I'm going which direction? To the left. Now is this open or closed? It's open because it's not or equal to. It's just less than. All right? And so I do this. And then there you go. You're good. All right, let's do this one. Now we're doing some math here. All right, now we're putting some numbers in and doing something with these numbers. It's really not much different than we did on the first quiz, except the fact that we're actually plugging numbers in for x and y. All right? But we're just multiplying and adding is really all we're doing. So what's happening here? 5xy. What's happening to that 5 and that x and that y? They're all multiplying together, aren't they? All right, so I put a 5, and then I'm going to put a parentheses for the x and a parentheses for the y, and then I'm going to put plus 2. Isn't that the same as that? Let's plug in the numbers. What is the x? It's negative 2, so I put a negative 2 right here. What is the y? It's positive 3, so I put the 3 right there. Now, order of operations. Remember the PEMDAS thing? Do multiplication first. So we got to do those things first. Let's do that. 5 times negative 2. Negative 10 times 3, negative 30. And then Now I can add them together. Negative 30 plus 2, it's negative 28. Now look, I would like you to be able to do that in your head, all right? You should be able to do that in your head, but I'm letting you use a calculator, all right? So you could always put that into a calculator, all right? Okay, here we go. Let's do this. Same kind of thing. What's happening to that 3 and x? They're multiplying together. So I'll put the x, I'll put a parentheses where I'm going to put the x, and then put a plus, and then it's 2 times the y, and this is what? The bottom, 2 plus y, right? I'll put the y right there. So let's go back to the top. 3 times x. What is the x again? It's the same thing right here. X is negative 2, y is 3. So put a negative 2 in for the x and a 3 in for the y. This is 2 plus y, or 2 plus what? 3. So all I did was just replace the x and the y with what they're equal to. Just plug it in, right? Just, oh my gosh, my brain went south. Substitute, that's the word. Substitute, all right, in for that. Now, what do? Same thing that we did on the first quiz, same thing we did here. What do we do first? We do the multiplication first. So I multiply those together, I multiply those together. With me? So what's 3 times negative 2? That's negative 6. Then you put a plus, and now you go 2 times 3, which is positive 6, over, what's 2 plus 3? 5. Now watch what happens. Now I just simplify the top. Negative 6 plus 6 is 0 over 5. What's 0 divided by anything? It's 0. All right? And that's your answer right there. It's really pretty easy once you get those rules down, right? Once you establish what you do first and knowing that you multiply these things together, it's really not that bad. Let's keep going. Again, you can always watch the video, go back, pause it, try it yourself. But I'm going quick because we got to get out of here soon. Absolute value. So I can put a little absolute value here. It's just x minus y. So what is the x in this situation? Look, this x and y, somebody, I remember, I have no idea who did it, but I remember somebody put the same x and y from the other problem into this problem. But these are two different problems. This has positive 3 for the x and then a negative 2 for the y. Everybody see that? So you got to make sure you know what you're doing. So x is what? 3 minus, what's y? Negative 2. Keep it an absolute value. Figure out what's in the absolute value first. Minus a negative. What do we do with minus a negative? Make it a plus. So 3 plus 2 is 5. What's the absolute value of positive 5? It's just 5. The absolute value just keeps it positive. All right? You work the stuff inside the absolute value first. Get an answer. Then the very last thing you're going to do is take the absolute value of it. Let's do this one. Now, they split these up. It looks kind of the same, doesn't it? But it's a little bit different. So it's the absolute value of x. What is x? It's 3. So the absolute value of x minus the absolute value of y. What was y? Negative 2. All right, but we put it inside the absolute value. Let's simplify it. What's the absolute value of 3? Positive 3 minus, right? That's not in an absolute value, is it? That minus. So we just write a minus. What is this? What's the absolute value of negative 2? It's positive 2. So we're done with the absolute values, aren't we? So now you just go 3 minus 2, which is 1, and then there you go. Probably the hardest thing on all 3 of these quizzes are these 2 right here, okay? So watch very carefully. Everything in the parentheses is being cubed, taken to the 3rd power. So I got to take everything to the 3rd power. So I'm not even going to write it down. I'm just going to do it in my head. X to the negative 1st to the 3rd. We have a thing called the power rule. What does that power rule tell us? When you have an exponent taken to another power, what do? You multiply them together. So this is going to be x, you keep the base the same, and multiply the exponents. What's negative 1 times 3? Negative 3. Let's keep going. Now you have a y. It's a y to the 1st, if you want to look at it like that. So y cubed, which is just y cubed. But look at the question, or look at the problem. It says express the answer so all exponents are what?
Positive.
Positive. Are all the exponents positive here? No. Which one is not positive? The x. So what do I do with that? I flip it, right? I flip it. Take it down to the bottom, and now I'm going to make it positive. So how? How do I write it? Y cubed over x cubed. And that's my answer. We good? Let's do this one. This is the one that was the big problem. So here's how I would do this. This thing right here, I'm not going to flip anything yet. I want to simplify the top until it's completely simplified. I want to simplify the bottom until it's completely simplified. Then I'll look at it and decide if I need to flip anything. You hear what I just said? Go back, watch the video, listen to what I just said, okay? So I'm going to keep that the way it is. Then I'm going to take everything in here to the negative first power. So I've got y to the negative first power, and I have what? Z to the negative first power. See how I took everything in here to the negative first? Over, what about the bottom? I can simplify one little thing. What's 2 cubed? 2 times 2 times 2. It's 8, all right? So there's an 8. And then I can't really do anything with that, so I just write x to the fourth y. I didn't do a whole lot. All I did was 2 cubed, and then I took this y and z to the negative first. That's all I really did, right? Didn't flip anything. Everything's simplified on the top, everything's simplified on the bottom. I can't keep it like this because I got x's on the top and the bottom. A lot of you guys kept it like this or something similar to it. All right, you had x's on the top and x's on the bottom. You can't do that. All right, so
can I ask Gianna Wade down to guidance, please?
In about 5 minutes, we're finishing up a quiz.
Okay, thanks.
She's always taking kids out of my class. All right, so watch. This is a negative exponent, correct? So where do we want to move it? To the bottom. I'm going to move it to the bottom. I'll rewrite it in a minute, okay? A little sloppy right now. What else do I have? That's a negative exponent. Where do I move that? To the bottom. This is a negative exponent. Where do I move that? To the bottom. You following me? Why did I do that? Because I don't want any negative exponents. All my exponents need to be positive. So let's move everything. Here's another thing I could do. I got a 4 on the top and an 8 on the bottom. We've done that once already today. That goes once, this goes twice. So I got a 2 on the bottom. Let's do the x's now. I already had an x to the fourth on the bottom, didn't I? Yep. What else is going to be on the bottom now?
2.
No, not a 2.
Wow.
An x squared. It's not a 2. I know, but you didn't say it right. I know what you meant, but you got to say it right. So this goes to the bottom. It leaves it here, goes to the bottom, makes it x to the positive 2. Let's do the same thing with the y's. I already got a y down here, so I'll keep that y right there. Now what do I do with this? Flip that to the bottom, and it becomes what? Another y. Not y to the 2. It wouldn't be to the 2 anyway. You wouldn't say that. You'd say to the second. This is a y to this negative second. All right, don't get ahead of me. Just answer my questions. I know what you were thinking again. So y to the negative second, we flip it to the bottom. It leaves here, and it becomes another y to the first. One more. What else we got to do? Take that z, flip it to the bottom. So it leaves here, and it goes to the bottom and becomes what? Z to the positive first. What's left on top? Looks like everything canceled out. But yeah, I got a 1 left on top. We're almost done. One more step, and this problem's over. So I got a 1 on the top. I got that 2 on the bottom. Let's combine the x's. X to the fourth times x to the second. Again, we have a rule for that. When you have the same base, what do you do with the exponents? You add the exponents together. So this would be x to the 6. I'm done with those. What about the y's? Y to the first times y to the first is y squared. And then, what else? Just a z, and there you go. That is your answer. It's the most complicated problem on all 3 quizzes, probably. Okay? Let's do this. Where is the decimal right now? It's here. Where do you want it to put it in scientific notation? Yeah, in between the 3 and the 2. So I'm going to write 3.2, and then write out the rest of it as well. Some of you guys just stopped at 3.2. Write the other numbers as well. And then we write times 10 to something. This moved how many places? 1, 2, 3, 4. Is it going to be a negative 4 or a positive 4? This moved to the left, so this moves to the right. And that is scientific notation. All right, I hate the fact that we didn't finish, but I need to go over this tomorrow. So we're going to postpone the test from Thursday to what? Friday. So we're going to take the test on Friday because I really want to go through this quiz with you guys. Okay.